Hi guys, we're going to have a look at question 6 from exercise 5b. These ones here you have to actually solve for x, so let's just do a couple of these from there because there's a lot to do. So we'll do number A first of all, so 6a. So if I've got e to the 2x, e to the x equals 2, well, the way we get rid of e is simply by taking the ln of both sides. So if we go ln of e to the x, and that's equal to ln of 2, the ln and the e's really cancel each other out, so that leaves me with x equals ln of 2. Alright, so that's as simple as it needs to be. We're going to something a little bit more complex. We might do something like g as an example. So if we got e to the x plus 2 equals 3e to the minus x. Now, I don't know about you, but I never really like minus power. So the way we get rid of this one over here is we multiply that by e to the x. Alright, so if I do that, then e to the x times by e to the x is going to give me e to the 2x plus 2e to the x, and then e to the minus x and e to the x, when we're adding the powers together, will give me e to the 0, which is simply 3. Alright, so we will look at that in class maybe, if you're not quite sure of that. Now I want to rearrange that if I can. E to the 2x plus 2e to the x, take 3 equals 0. Alright, now what I want you to think of this as, I want you to think of this being a little bit like x squared plus 2x take 3 equals 0. Now, if we were doing that, we would factorise that as x. Alright, then we'd have 3 and 1, and then we'd go, the big number has to be the positive, the little number has to be the negative, and that would be equal to 0. So that's the way I want you to think of this when we're doing it. Alright, so in terms of now solving that question, what I need to do is I need to say, well, the x is in fact e to the x minus 1. That's going to be e to the x, because that's how I get e to the 2x anyway, isn't it? And then it's going to be plus 3 equals 0. Now, what that means is e to the x take 1 equals 0, so that's equal to e to the x is equal to 1, or e to the x is equal to minus 3, for that to be the case. Now, with this thing, if we go back to our graph of e to the x, now we know that e to the x is never negative, right? And it always has to be positive. So therefore, what we can say for this one over here is, and you need to use mathematical terminology with that, which is really important for doing this. We need to say that e to the x has to be greater than 0, so therefore that's not possible. Alright? Now over here, if we're doing our solving for that, now we're going to take the ln of both sides. Remember, we do that, then x is equal to simply ln of 1, and in that case there, ln of 1 is actually equal to 0 anyway. Alright, if you do that on your calculator. So that's how you do exercise 6. Question 6 is you doing that. Now, if I want to do something for 7, I need to solve that. Let's do another colour for you so it stands out. Let's do, say, A for you. So 7A. If I'm solving that, it's going to be ln of that. I'm going to use my ln laws, okay, to do this. So ln of that. Now, remember the law is we're going to multiply together. So that's going to be x times by x plus 2 equals ln of 8, isn't it? And then over here we're going to go, that's ln of well, we might as well times it out, x squared plus 2x, and then it's going to be take ln of 8 equals 0. So therefore that I can combine that again as ln of x squared plus 2x, should be next there, all over 8 is equal to 0, isn't it? So I'm solving this for x. Now, in other words, I could put these both to the power of e, couldn't I? Alright, so therefore if I put these both to the power of e, anything to the power of 0 is going to be 1, so therefore what we've got over here is we could say that that's e to the power of ln will just give me x squared plus 2x all over 8, and that's equal to 1, and so therefore x squared plus 2x equals, now times the 8 up, that's 8, and then now you've pretty well got a quadratic we can actually solve. So I'm not going to go any further with that. I think that sort of gives you the idea of what you need to do there. That's fairly rare that you see that. You're more likely to see one like this one over here. Alright, so that's the sort of one that we get you to do. When we start looking at the next bit, the next skill that you need for this one here, we'll have a look at question 8. You expect to find algebraically the points of intersection. Now, the first thing that you need to understand is you can put those two functions into your calculator and you can graph those and you can find the intersection point. That's one way of doing it. And the other way of doing it is to do it algebraically. Now, we know if they're going to meet, then they have to have the same y coordinates at that point. So if we just did number A, first of all, so AA, if we have something like intersection, we know that e to the x must be equal to e to the 2x takes 6. Alright, so in other words, if that's the case, then we simply are going to rearrange that. We're going to say therefore e to the 2x take e to the x take 6 is equal to 0, and then we're going to solve that, remembering thinking that like being big X, so that's going to be e to the x, e to the x. Okay, now 6 is going to be 3 and 2. The big one has to be the negative one because it's negative. That's equal to 0. So therefore, e to the x is equal to negative 2. Okay, or e to the x is equal to 3. Now we can say that the first one's not possible. Right, so that's not going to be possible because e to the x has to be greater than 0, and so therefore over here the only solution that we're going to have is x is equal to ln of 3. Now we have to find the intersection point, so it's only going to intersect that one point, isn't it, for this particular curve, and we know the point is going to be ln of 3. Now the way I would do this in a question would be to say find the exact point of intersection. If I find the exact point of intersection, that would mean that if you graphed it, you'll probably get a decimal. Remembering these are irrational numbers, so the easiest thing to say then would be y has to be equal to e to the x value, now ln of 3. So therefore when we do that, that's going to give me a value of 3. So the point of intersection is going to be ln of 3, and then the answer 3 is my y coordinate. So that's the only point of intersection. If you want to check that in your calculator, you could certainly graph that. Okay, I'm not going to do that, but you can just graph that and you can find that point. The only difference is, if we were looking at this value here is going to give you a decimal point. Okay, ln of 3, I don't know what that works out to be, but it's going to give you a decimal point. So again, I'll just reiterate, if I'm going to ask you a question in a test and I want you to do the algebraic way, I'll use the word find the exact value for that. Right, so have a go at those questions. I'm going to do one of the extended questions in part B in the next video.